So we're going to be solving equations that have radicals in them, or solving equations that have fraction exponents. So whenever I say rational exponent, I mean fraction exponent. You already know how to solve some equations that have exponents. Like, you know how to solve x squared equals 36. You square root both sides. Okay. So be thinking about how you solve things that have regular whole number exponents, and maybe make connections between that and what we do today. On the first slide, I'm going to give you some time just to copy everything down, and then we'll work through and actually solve the problem on the first slide. Okay, so if you would, copy this information and this problem, and then we'll work through that problem shortly. Okay, so we're going to start with the equation over there that says we're taking the cube root of 2x minus 9 minus 1 equals 2. And we're going to read the directions that we have for solving radical equations, and we're going to make sure we follow all these things. So step 1, isolate the nth root, or what you might call the radical. That includes the symbol that is the radical, that includes its index, and then anything that's in the radicand, so the stuff underneath the radical. So is there anything that you need to do to isolate the radical in this equation? What should we move right away? And the x is trapped underneath the radical, so I don't think we can get it alone. I think we can add 1 to both sides. Okay. So the key here is the radical stops at 2x minus 9. So minus 1 is separate from the radical. So we're going to add 1 to both sides. That's what I mean when I say isolate the nth root or the radical. So we're going to add that 1. I'll write it as this cube root of 2x minus 9 equals 3. And maybe some people would prefer, like you could go in and you could box or circle, like what is the radical. It includes the index, it includes the symbol, it includes the stuff underneath. So any number that doesn't fit that needs to be moved right away. Okay, so we've isolated the radical. The cube root of 2x minus 9 is now all by itself. So we can move on to step 2, which is raise each side to the nth exponent. What's n in this problem?
3.
The 3, right? That's our index. So we want to raise both sides to the third. Okay, so to get rid of the cube root, cube both sides. That makes sense. So we're going to cube the left and cube the right. What will the cube do to the cube root? Make it disappear, right? Okay, just like a square root makes a square disappear. So they're inverses of each other. We have 2x minus 9 equals, what is 3 cubed? 27. Okay, you can see how using the flashcards and looking at the chart multiple times is going to be helpful here, because you're raising things to different exponents. And then the rest of my directions say solve. Do you know how to solve 2x minus 9 equals 27? What steps would you need to take to shout them out? Add 9 and divide by 2. Cool, let's do it. Add 9, 2x equals 36. Divide by 2, x equals 18. Okay, now there's one step here that we haven't completed yet, and that's to check your solution. Now, this check is different than normal checks. Do you remember, like in Algebra 1, when you first started solving stuff, and like every time you solved an equation, you also had to check it by plugging it back in to make sure you got the right answer? I mean, that's a good practice to have, especially on quizzes and tests, to make sure you have the right answer. But we're actually checking to make sure that the number we got is actually a solution, because in radical equations you can have something, and it's a really big word. Nope, I keep spelling it wrong today. called an extraneous solution. Okay. Now, extraneous, I'll use when I'm doing my work an abbreviation of EXT. So when I write EXT, I just mean that's extraneous. You can also use a word that probably makes a little bit more sense. False. That's what extraneous means. Now, the weird thing about extraneous solutions is they aren't wrong answers. Okay. You did everything right. All of your work is correct. But when you get your answer, it doesn't work when you plug it back in. That's a false solution. Okay, so that happens with radical equations. Okay. Sure, absolutely. So we're solving for extraneous solutions or false solutions. This is, like I said, different than getting wrong answers. Okay. Now, usually when I do a check for extraneous solutions, I do a mental check. Okay. So let's take 18 and plug it back in. What's 2 times 18?
36.
36. What's 36 minus 9? 27. What's the cube root of 27? 3, and 3 minus 1 is 2. Did you notice he went back through all the numbers that we had used in the problem? Okay, so we're just kind of rewinding, and you'll notice right away when it doesn't come out nicely. Okay, so all you have to do is make a quick check and make sure that it really works. Okay, so I want you to solve the next problem on the board. I'd like you to solve the square root of x plus 25 equals negative 2. So, I don't think so, right? If I think about what's the radical, remember the radical is the symbol, it's the index, and it's the stuff that's underneath the radical. So the radical really is all by itself. So we move on to step 2. Step 2 says raise both sides to the n. What is the index for a square root? It's really 2. We talked about that first day we introduced the radical. That even though you don't see it for a square root, you have to know that there's a 2 there. We don't write it because it's so common. Okay. So now we want to raise both sides to that value. So we're going to square both sides. Make sure that you're not doing the same thing. Like you're not square rooting both sides. You don't want to keep doing more square roots. You want to do the opposite operation, which is to square it. What do you get when you square it? X plus 25 equals 4. Thanks, Jace. X plus 25 equals 4. Because a negative 2 times negative 2 would be positive 4. And can you solve that equation? Yeah. So what's the answer? Yep, subtract 25 on both sides. So x equals negative 21. Now, what should I do with my answer? I should check my solution, Justin says. So we're going to take our negative 21 and we're going to plug it back in. So I'm doing the square root of negative 21 plus 25, and it's supposed to equal negative 2. What happens to negative 21 plus 25? It's the square root of 4. What's the square root of 4? Okay, so here's the question. Some people are going to say, oh wait, we need it to be negative 2, so let me add a plus or minus. We're not adding a plus or minus in this case because we're not solving right now. We're not working backwards and trying to get x all alone and taking square roots to solve. That's when we add plus or minus. All we're doing is simplifying. We're just evaluating down the line. So when I normally ask you guys what the square root of 4 is, what do you normally just say? You normally just say 2, right? When you're doing your flashcards, what do you normally answer for the square root of 4? 2. Okay, so we don't want to add the plus or minus here. We always assume the positive is the check. Okay, so I'm going to write that down. Assume the positive. And then is 2 equal to negative 2? No. So what kind of solution do I have? No solution, a false solution. We'll cross this out and call it EXT, or false. So there is no solution. Okay.
I thought it was 4 equals 4.
How? Did you plug it in right here?
Yeah. No. Yeah.
If you plug it into this step, you're right, it would work out, but that's not the original problem.
But when you raise it,
You don't want to do any, like, you're not really, like, when you do the check, you're literally just substituting negative 21 in for x. And then this side stays the same. Don't change anything. On the left side, you're just running through. What is the process? Oh, negative 21 plus 25 is 4. Square root of 4, normally I would just say 2. 2 is not equal to negative 2, therefore extraneous. That would be a challenge for some of us. We'll want to say like it's okay because when we solve, we say plus or minus 2. But when we're checking, we're just simplifying so we don't put the plus or minus. Okay. So that's an example of an extraneous solution. But we still did have all the math right. It just doesn't come out to work. What do you think about this problem? Square root of 2x plus 5 equals the square root of x plus 7. What did I change? There's a square root on both sides. Are the square roots all by themselves? They have stuff underneath, but isn't like that the whole radicand? Yeah, 2x plus 5 is the radicand and x plus 7 is the radicand. So I do think that the radicals are all by themselves. How do you get rid of that then? Square it, raise it to the 2. Okay, so let's square both sides. I mean, there's really nothing else to do. So square both sides. You'll get 2x plus 5 equals x plus 7. Can you solve that equation? Oh yeah, that's an easy one from Algebra 1. Multi-step. I'd subtract x from both sides. And then I would have x plus 5 equals 7. And then I'd subtract 5, and I'd come up with x equals 2. What should I do? Check my solution real quick. In the left one, 2 times 2 is 4, plus 5 is 9, so the square root of 9 is 3. On the right side, 2 plus 7 is 9, square root of 9 is 3. It works out. Cool. Okay, so just because it has 2 radicals doesn't mean it's extremely hard. It actually might be easier than the other one. Here's a different problem. X plus 1 equals the square root of 7x plus 15. When you see something like this, still go back to your original set of rules. Is the radical all by itself, isolated? Eric is shaking his head. Yes. Everything else is on the other side, right? So how do you get rid of the square root? You are going to square both sides, and you are going to come up with an x squared. You just need to talk about how that happens, right? So we're going to square this side. No problem. That'll just cancel out the radical. But then I want to square all of the left side. So I have to put that x plus 1 in parentheses. And then I have something like x plus 1 squared equals 7x plus 15. How do I simplify x plus 1 squared? Can I just say x squared plus 1? That would be nice, wouldn't it? Oh, thank you. You create 2 binomials. It is x plus 1 times x plus 1. That's what it means to square that, doesn't it? So then I have to FOIL it out. X times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. So we get x squared plus 2x plus 1. I'm just using FOIL or multiplication. We practiced that a lot in our last chapter, chapter 4. So if you're still having troubles with multiplication of binomials, stop in and see me. But everybody should be able to FOIL stuff out. So that's the left side. X squared plus 2x plus 1 equals 7x plus 15. Now how in the world am I going to solve that equation? If I have x squareds and x's. What's that? What, oh, like come up with a polynomial and you said combine like terms? Okay, was there a hand in the back? No? I dreamed that? Okay. So yeah, I think, like, you notice that you have x's on both sides and your numbers on both sides? Let's get everything on one side, right? So I'm going to subtract 7x. And then I'm going to subtract 15. So I have x squared minus 5x minus 14 equals 0.
Yeah.
And what can I do to solve x squared minus 5x minus 14? Unfoil it, right? Factor it. Okay. Do you have factors of negative 14 that add to make negative 5? Negative 7 and 2. So it'll be x minus 7 and x plus 2 equals 0. So x equals 7 and negative 2. Notice that like what we did in our last chapter is still working for us in this chapter in terms of solving polynomials. What should I do with both of those numbers? Plug them in and check them. Okay. So 7 plus 1 is 8. And then 7 times 7 is 49. Plus 15 is 64. And the square root of 64 is 8. So 7 checks. And then I'm going to check negative 2. Negative 2 plus 1 is negative 1. And then this will be 7 times negative 2, which is negative 14. Negative 14 plus 15 is positive 1. The square root of 1 is 1. Does this one work? No. So you really have only one answer. You have one false solution and one that works. You could have a quadratic solve and you get 2 solutions and then both work. So it doesn't have to be that one is extraneous. Just sometimes it is. Okay, so that's definitely one of the like harder problems because you have to FOIL and then you have to factor. Okay. Well, one other thing that I need you to get down, and that is solving equations with fraction exponents. So I'll give you some time to write this down, and then we'll run through the example. A problem like this is going to be a problem where you could really see the benefit of doing the flashcards each day. Okay, so if you haven't been taking the time on flashcards to really like practice using the chart and practice working with fraction exponents, here's why we need to be really good at that. Okay. We have the equation, the quantity 2x raised to the 3/4 plus 2 equals 10. Start at step 1. Is there anything you need to do to isolate the fraction exponent and its base? Anything you need to move right away? The 2. So we're going to have to subtract 2 from both sides. So we're going to take care of that right away. We'll have 2x raised to the 3/4 now equals 8. So I have the exponent 3/4, bless you, and whatever you're touching, 2x, all by itself. And now I can raise each side to the reciprocal of the fraction exponent. So what's the reciprocal of 3/4? 4/3? And when you do 3/4 raised to the 4/3, you'd end up multiplying those exponents, and when you multiply reciprocals, they come out to be just 1. So on the left side, you just have 2x. These things will cancel out. And you have 2x equals 8 to the 4/3. This is your flashcard. How do you evaluate 8 to the 4/3? Think about it like, right? Cube root of 8 and raise it to the 4th. Thank you. What is the cube root of 8? 2 to the 4th is 16. So 2x equals 16, divide by 2, and x equals. So the benefit of practicing with the flashcard is that when solving, that's only the tiniest of hiccups. You're like, oh, 8 to the 4/3, the cube root of 8 raised to the 4th. Cool. I'm ready to keep going. Okay, your homework assignment, you should check that solution, but it does work out. Sorry. Your homework assignment for tomorrow is here. And I will, like I said, I will leave a copy of my answer key for this book assignment with the sub. So if you ask, you might be able to check your answers to tonight's homework if you need to see if you're doing it right. And then I will have an assignment for you. Okay.